Hi one and all. So in last session we discussed cyclic group and some examples of a cyclic group and some properties of cyclic groups. Okay. So in today's session also I'd like to continue some more properties of a cyclic group. So let us see this theorem. Okay, if A is a generator of a cyclic group, so cyclic group G is generated by an element A, so then definitely order of an element A is same as order of a group G. Order of an element A is same as order of a group G. So that means the order of the group is always is equal to order of the generator. So order of the group ಮತ್ತೆ order of the generator ಎರಡು ಕೂಡ ಏನಾಗಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Yes, to prove this theorem, I don't know what is the order of an element A is. Okay, just I am imagining that order of an element is a number n. So when n is the least, so order of an element A is n. Okay, so take the proof of this property. Take its proof as let. So you take let order of an element A is equal to n. So that means if order of A is n, order of A is n, then A to the power of n is equal to E, such that n is the least positive integer such that A to the power of n is equal to E. So therefore, we write that n is the least positive integer, least positive integer. N is the least positive integer such that A to the power of n is equal to E. Okay, so next you consider one set. Consider the set. So ನೀವು ಒಂದು ಸೆಟ್ ನ ತಗೋಬೇಡೋಣ ನಾವು. ಸೊ ಸೆಟ್ ಹೇಗಿರಬೇಕು ಅಂದ್ರೆ it is like this. The set H is equal to A square, A cube and so on. It should be like A to the power of n. As you know that A to the power of n is E, so you write it is A to the power of n is E. And clearly all these elements are elements of the group G. G na element, again G is the set, it is generated by an element A. So here H is the set consists of an elements which are generated by an element A. Okay, so H is the set like this: A square, A cube and so on. A to the power of n is equal to E. So these elements are distinct. These elements are distinct. So ನೀವು ಕೇಳ್ಬೋದು ಹೆಂಗೆ ಸರ್ ನೀವು ಇದು ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಡಿಸ್ಟಿಂಕ್ಟ್ ಇರುತ್ತೆ ಅಂತ ಹೇಗೆ ಹೇಳ್ತೀರಾ ಅಂತ. Okay, these elements are distinct. First to write it is distinct. Okay, so you may object that sir the elements may not be distinct ಅಂತ ಹೇಳ್ಬೋದು ನೀವು. ಸೊ ಎಲಿಮೆಂಟ್ಸ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ಇಲ್ದನೇ ಇರ್ಬೋದಲ್ಲ ಸರ್ ನೀವು ಹೆಂಗೆ ಹೇಳ್ತೀರಾ ಅಂತ ಕೇಳ್ಬೋದು. ಸೊ ಫಾರ್ ದಟ್, ಸೊ ಯು ಅಸ್ಯೂಮ್ ದಟ್ ಫಾರ್ ಇಫ್ I am assuming that two of the elements of H are same. H ಅಲ್ಲಿರೋ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಸೇಮ್ ಇದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಅಂದ್ಕೊಂಡ್ರೆ ಏನ್ ಬರುತ್ತೆ ರಿಸಲ್ಟ್? ಲೆಟ್ ಅಸ್ ಸಿ ದಟ್. ಸೊ ಇಫ್ A to the power of R is equal to A to the power of S. So R ಮತ್ತೆ S n ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. So where R and S are like this, where 0 less than or less than S and both are less than or is equal to n. So then you operate both the sides with A to the power of minus S because it is a group. ಇದು ಗ್ರೂಪ್ ಇರೋದ್ರಿಂದ A to the power of S G ನಲ್ಲಿ ಇರುತ್ತೆ ಅಂದ್ರೆ A to the power of minus S is also an element of G because A to the power of minus S is the inverse of A to the S. So you write like this: A to the power of S into A to the power of minus S. Now, so you can write this one as A to the power of R minus S is equal to A to the power of S minus S. You can write it is A to the power of 0. That is A to the R minus S is equal to A to the 0 means that is an identity element. A to the 0 is identity element. And all of you know that R and S are the values which are less than n. n ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅದು R ಮತ್ತು S values. So R minus S is an L number. It is definitely less than n since 0 is less than R minus S. R minus S definitely it is greater than 0. Okay, and it is less than n. So actually when we are raising the power of a to r minus s, it gives the identity element. So actually a to the power of n is also e, and also we know that n is the least positive integer such that a to the power of n is equal to e. Okay, but when we are putting the r minus s in the power of a, that also gives e. And also you see this r minus s is less than n. Is this possible? R minus s n ಗಿಂತ ಕಡಿಮೆ ಇದೆ. Okay, this is impossible because n is the least, according to our assumption, n is the least positive integer such that a to the power of n is equal to e. So r minus s, it may not be less than n. So we are getting this type of wrong result because of our assumption. What is our assumption? ನಾವೇನು ಅಂದ್ಕೊಂಡಿದ್ವಿ? I to the r is equal to a to the s. So that means the two of the elements of h are same. Two of the elements of h are same. h ನ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಸೇಮ್ ಇದೆ, ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ವಿ. That is wrong here. Okay, so that is the contradiction. This contradicts the fact that, okay, write that this contradicts the fact that this contradicts the fact that n is the least positive integer. N is the least positive integer. N is the least positive integer such that a to the n is equal to e. A to the power of n is equal to e. So therefore elements of h are distinct. So the elements of h are distinct. So initially we consider a set h and then we take that two of the elements of h are same, and finally we conclude that all the elements of h are distinct. All the elements of h are distinct. ಯಾಕೆ ಅಂದ್ರೆ ಎರಡು ಎಲಿಮೆಂಟ್ ಸೇಮ್ ಇದೆ ಅಂತ ತಗೊಂಡ್ರೆ ನಮಗೆ ರಾಂಗ್ ರಿಸಲ್ಟ್ ಬರುತ್ತೆ. a to the power of r minus s is equal to e ಅಂತ ಬರ್ತಾ ಇದೆ. So that means our assumption is wrong. That is a to the power of r is equal to a to the power of s is wrong. Okay, that is not possible. So again, now you take one element from this set g. Okay, so g ಇಂದ ಒಂದು ಎಲಿಮೆಂಟ್ ತಗೋಣ. So let g is an element of g. So let g is an element of g. So let us take that. Okay, no problem. Let g is an element of g. G belongs to g be an arbitrary element. So g is an element of g. Okay, such that you see, if g is an element of g, so if g is an element of g, so all the elements of g are, we can express all the elements of g in powers of a. Okay, so g is an element of g, then g also can be written in powers of a. So g is an arbitrary element of g such that you take that g is equal to a to the power of m, where m is any positive integer. G is equal to a to the power of m. Next, you take that division algorithm for the elements, the numbers m and n. m ಮತ್ತು n ಗೆ division algorithm apply ಮಾಡಿ. So then by division algorithm, you know division algorithm? So okay, Then by division algorithm, I will explain that. Then by division algorithm, there exists integers q and r, there exists integers q and r such that we can write m as m is equal to nq plus r, where this r is greater than or is equal to 0, less than or is equal to n. So hope you understand the division algorithm. ನೀವು ಯಾವ್ದಾರ ಎರಡು ನಂಬರ್ಸ್ ತಗೊಳ್ಳಿ, ಅವೆರಡಕ್ಕೆ ಡಿವಿಷನ್ ಅಲ್ಗಾರಿದಮ್ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 2 ಮತ್ತೆ 3 ಅಂತ 2 ಮತ್ತೆ 5 ಇಟ್ಕೊಳ್ಳೋಣ. We can write 5, you divide the number 5 from 2, 2 2s are 4, remainder is 1. So we can write 5 as 5 is equal to 2 into 2 plus 1. Okay, this number should be less than this element 2 ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. So like that, we can express this 2 in terms of 5 like this. 2 is equal to 0 into 5 plus 2. 2 is equal to 0 into 5 plus 2. So what is r here? R is 2. Is this r is less than or is equal to n? N ಅಂದ್ರೆ ಏನು? What is the n here? N is 0. So that remainder S2 can be written as 0 into 5. Yes, what is n? N is 5 here and m is 2 here. So this number 2 is less than or is equal to 5. Okay, less than 5 actually. So this is the method of division algorithm. Division algorithm ಅಲ್ಲಿ ಒಂದು number na express ಮಾಡೋದ್ರಿಂದ. You take any two numbers and we can express that in division as rule of division algorithm. So that is m can be written as nq plus r, where r is the value less than or is equal to n and it is greater than 0. R is greater than 0. So therefore g can be written as you know that g is equal to a to the power of m, g is equal to a to the m, which is equal to a to the power of nq plus r, which is equal to a to the power of nq into a to the power of r, which is equal to a to the n whole to the q into a to the r. As you know that a to the power of n is equal to e. ಇಲ್ಲಿ ಬರ್ದಿದೆ a to the power of n is e ಅಂತ. So it is e into a to the r, which is equal to a to the power of r. What is the value of r? R is the value less than n. So a power r means a to the power of, so that is g can be written as g is equal to a to the power of m, which is equal to a to the power of r. So r is the value less than or is equal to n. That means a ನ ಪವರ್ n ಗಿಂತ ಕಡಿಮೆ ಇದ್ರೆ ಅದು ಈ ಸೆಟ್ ಒಳಗಡೆ ಇರುತ್ತೆ. So this is the element belongs to the set H. So g is equal to a to the power of r and r is less than or is equal to n. So clearly, so therefore you write g is an element of H. Like this you can show that all the elements of group G is an element of H. ಇದೇ ತರ ನೀವು ಗ್ರೂಪ್ ಜಿ ನಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಎಚ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ತೋರಿಸ್ಬೋದು. ಹಾಗಾದ್ರೆ so therefore group G is subset or is equal to H. But the fact is H is subset of G. H is subset of G. Okay. G is subset of H. H is subset of G. It is possible only when G is equal to H. This is possible only when G is equal to H. Group G is equal to H. Okay. So if G is equal to H, then order of G must be is equal to order of H. G is equal to H ಆಗೋದಾದ್ರೆ order of G ಮತ್ತೆ order of H ಎರಡು ಕೂಡ ಸೇಮ್ ಇರಬೇಕು. So order of G is equal to what is the order of H? H ಅಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ? Yes, clearly H consists of n elements because a power 1, a power 2, a power 3, like that a power n is the last element. and none of the elements are repeated, all elements are distinct here, so it consists of clearly n elements. It consists of clearly n elements, so order of h is n. Order of h is equal to n, and order of g is equal to is what is the order of an element A? What is the order of an element A? Order of A is n. Initially we take that order of A is n. So here in place of n we can write it is order of A. N plus n baribodu. We can write it is order of A. Okay. So this is because H consists or H contains H contains n elements. H contains n elements. Order of G is equal to order of H. Yes, actually that one we are going to prove. Order of G is equal to order of H. Ade now prove madakoltiದ್ದು. As here we proved that order of G is equal to order of H. Okay. Similarly, you consider one more. See one more property here. If G is a finite group of order n. So G is a finite group, that means it consists of finite number of elements, and order of G is n. Order of G is n containing an element of order n. So G consists of an element. The order of that element is also n. So then definitely G is cyclic. You have to show that G is a cyclic group. Okay. To prove that, as it is very simple property. First you take one element from group G. So take its proof. Okay, you take let A is an element of group G. A is an element of G. So that be an element. A belongs to G, be an element of order n. You take its order is n. So in the property itself they are given that G consists one element of order n. What is n? N is the order of the group G. So a group na order irodu ಎಷ್ಟು n. So n order n ಇರುವಂತದ್ದು ಒಂದು ಎಲಿಮೆಂಟ್ ಗ್ರೂಪ್ G ನಲ್ಲಿ ಇದೆ. ಯಾವುದದು? So we take that element is A. So now you take let you consider one cyclic group. So that is H. ಒಂದು cyclic group ತಗೊಳ್ಳೋಣ ನಾವು. ಅದು A ಇಂದ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಆ cyclic group ನ H ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. So let H be the cyclic group generated by an element A. So H ಯಾವುದರಿಂದ ಜನರೇಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ so A ಇಂದ ಜನರೇಟ್ ಆಗುತ್ತೆ. So H is generated by an element A. So ಲಾಸ್ಟ್ ಪ್ರಾಪರ್ಟಿನಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಿ, ಒಂದು ಸೈಕ್ಲಿಕ್ ಗ್ರೂಪ್ ಇದೆ. ಸೊ ಅದರ ಜನರೇಟರ್ ಮತ್ತೆ ಆ ಗ್ರೂಪ್ ನ ಆರ್ಡರ್ ಎರಡು ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಸೇಮ್ ಆಗಿರುತ್ತೆ. ಸೊ and also you write that therefore H is generated by an element A. So because of closure property, all the elements of H are the elements of G. H ಅಲ್ಲಿರೋ ಎಲಿಮೆಂಟ್ಸ್ G ನಲ್ಲಿ ಇರುತ್ತೆ. ಯಾಕೆಂದ್ರೆ H ಜನರೇಟ್ ಆಗಿರೋದು A ಇಂದ. A ಎಲ್ಲಿದೆ? ಗ್ರೂಪ್ G ನಲ್ಲಿದೆ. ಸೊ H ನ ಎಲಿಮೆಂಟ್ಸ್ ಡೆಫಿನೆಟ್ಲಿ G ನಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ H is a cyclic subgroup of G. Okay, I think it's clear. Since what is the order of A? Order of A is n. And what is the order of H? Order of H is also n. Because n ಅಂತ ಹೇಗೆ ಹೇಳ್ತೀರಾ? ಹೇಗೆ ಹೇಳ್ತೀವಿ ಅಂತಂದ್ರೆ ಆರ್ಡರ್ ಆಫ್ H n ಅಂತ ಹೇಗೆ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ ಒಂದು ಸೈಕ್ಲಿಕ್ ಗ್ರೂಪ್ ಇದೆ, ಅದರ ಜನರೇಟರ್ ನ ಆರ್ಡರ್ ಮತ್ತೆ ಆ ಗ್ರೂಪ್ ನ ಆರ್ಡರ್ ಎರಡು ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ a ನ ಆರ್ಡರ್ n ಇದೆ ಅಂದ್ರೆ h ನ ಆರ್ಡರ್ ಕೂಡ n ಇರುತ್ತೆ. ಆಕ್ಚುಲಿ n ಅಂದ್ರೆ ಏನು? n is the order of group g ನ ಆರ್ಡರ್ ಅದು. ಸೊ you can write n as order of group g. So therefore, and also you know that also h is subset or equal to g. h is subset or equal to g. So therefore, ಅಂದ್ರೆ h ಅಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ g ನಲ್ಲಿದೆ. ಹಾಗೇನೆ h ಅಲ್ಲಿ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಷ್ಟೇ ಎಲಿಮೆಂಟ್ಸ್ g ನಲ್ಲಿದೆ. ಹಾಗಾದ್ರೆ h ಮತ್ತೆ g ಎರಡು ಸೇಮ್ ಅಂತ ಅರ್ಥ ಆಯ್ತು. ಸೊ therefore h is equal to g. Therefore h is equal to g. h ಏನು? h is a cyclic group. H is a cyclic group. If H is a cyclic group, then G is also cyclic group because H and G are one another the same. ಎರಡು ಒಂದೇ ಇದೆ. So therefore, G is cyclic. G is cyclic. Yes, I explain this proof again. So you take, now you have to show that G is a cyclic group. To prove that G is a cyclic group, you take one element A from G and you take its order is n. ಸೊ ಅಕಾರ್ಡಿಂಗ್ ಟು ಡಾಟಾ ಅವರೇ ಹೇಳಿರೋ ತರ ಸೊ ಒಂದು ಎಲಿಮೆಂಟ್ ಇರುತ್ತೆ, ಅದರ ಆರ್ಡರ್ ಕೂಡ ಈ ಗ್ರೂಪ್ ನ ಆರ್ಡರ್ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆರ್ಡರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ ಎ ಈಸ್ n. ನೌ ವಿ ಕನ್ಸಿಡರ್ ಒನ್ cyclic group that is generated by an element a. So H is a cyclic group that is generated by an element a, and all the elements of H are the elements of G because of closure property. ಯಾಕೆ ಅಂದ್ರೆ ಸೊ ಈಗ a ಇಂದ ಜನರೇಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ಓಕೆ, ಸೊ ನೀವೇನ್ ಮಾಡ್ತೀರಿ, a to the power of 1 ತಗೊಳ್ತೀರಿ. ಸೊ ದಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು H. a power 2, so or a power 2 means it is a star a, that belongs to H. According to closure property, if a is an element of G, a star a is also an element of G. So like this, all the elements of H are elements of G. So H is a cyclic group and the elements of H are the elements of G. And we consider that ನಾವೇನ್ ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ H ನ cyclic group of G ಅಂತ ತಗೊಂಡಿದ್ದೇವೆ. And in next step you take that order of A is n. ಹೇಳಿರೋ ತರ ಇಲ್ಲಿ ಇನಿಷಿಯಲಿ ನಾವು ತಗೊಂಡಿರೋ ತರ ಆರ್ಡರ್ ಆಫ್ ಎ ಏನಾಗಿದೆ, n ಇದೆ. ಅಂಡ್ ಆರ್ಡರ್ ಆಫ್ H is also n because of previous property. ಲಾಸ್ಟ್ ಪ್ರಾಪರ್ಟಿನಲ್ಲಿ ಏನ್ ಹೇಳುತ್ತೆ, ಸೊ ಒಂದು ಸೈಕ್ಲಿಕ್ ಗ್ರೂಪ್ ಇದೆ, ಅದರ ಆರ್ಡರ್ ಅದರ ಜನರೇಟರ್ ನ ಆರ್ಡರ್ಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳುತ್ತೆ. ಸೊ ಜನರೇಟರ್ ಯಾವುದು ಇಲ್ಲಿ ಎ ನ ಆರ್ಡರ್ n ಆದ್ರೆ H ನ ಆರ್ಡರ್ ಕೂಡ n ಇರುತ್ತೆ. ಆಕ್ಚುಲಿ n ಅಂದ್ರೆ ಏನು, n is the order of G. ಓಕೆ, ಸೊ ಅಂಡ್ H is the subset or equal to G. ಹಾಗೇನೆ H ಮತ್ತೆ n ಅಲ್ಲಿ ಒಂದೇ ನಂಬರ್ಸ್ ಎರಡರದು ಆರ್ಡರ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ H ನಲ್ಲಿರೋ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ G ನಲ್ಲಿ ಇರುತ್ತೆ ಅಂದ್ರೆ G ಮತ್ತೆ H ಎರಡು ಸೇಮ್ ಬಿಕಾಸ್ ದೇ ಕನ್ಸಿಸ್ಟ್ಸ್ ಆಫ್ ಸೇಮ್ ಎಲಿಮೆಂಟ್ಸ್. ಓಕೆ, ಸೊ H is cyclic group ಆಗೋದಾದ್ರೆ G is also cyclic group. ಓಕೆ, ಎಸ್, ವೆರಿ ಸಿಂಪಲ್ ಪ್ರೂಫ್, ಬಟ್ ತುಂಬಾ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಿದೆ, ಒಂದೊಂದು ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಮೀನಿಂಗ್ ಇದೆ, ಅದನ್ನ ನೋಡ್ಕೋಬೇಕು ನೀವು. ಓಕೆ, ಸೊ G is a cyclic group. Yes, before going to this property, I will give an example. As you know that fourth root of unity is generated by I. Fourth root of unity ಇದೆಯಲ್ಲ, ಏನಿರುತ್ತೆ ಅದ್ರಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ 1 minus 1 I minus I ಇರುತ್ತೆ. ಯಾವ್ದ್ರಿಂದ ಜನರೇಟ್ ಆಗುತ್ತೆ, I ಇಂದ ಜನರೇಟ್ ಆಗುತ್ತೆ. I ಕ್ಯೂಬ್ ಇಂದನೂ ಜನರೇಟ್ ಆಗುತ್ತಾ, I ಕ್ಯೂಬ್ ಇಂದನೂ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ I ಕ್ಯೂಬ್ ಅಂದ್ರೆ ಸೊ ದಟ್ ಈಸ್ ಮೈನಸ್ I, ಅಂಡ್ ಮೈನಸ್ I is also generator of this group. ನಾನು ಆವಾಗಲೇ ಹೇಳಿದ್ದೀನಿ ಇದು ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾದ್ರೆ, ಪ್ರೀವಿಯಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮತ್ತೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾದ್ರೆ. ಸೊ ಮೈನಸ್ I is also a ಜನರೇಟರ್. ಒಂದು ಗ್ರೂಪ್ಗೆ ಒಂದೇ ಜನರೇಟರ್ ಇರಬೇಕು ಅಂತ ಏನಿಲ್ಲ, ಬಟ್ ತುಂಬಾ ಜನರೇಟರ್ಸ್ ಕೂಡ ಇರ್ಬೋದು ಒಂದು ಗ್ರೂಪ್ಗೆ. ಓಕೆ, ಇದು ಒಂದು ಗ್ರೂಪ್ I ಅನ್ನೋದು ಒಂದು ಜನರೇಟರ್, I ಕ್ಯೂಬ್ ಕೂಡ ಒಂದು ಜನರೇಟರ್. I to the power 5 ಜನರೇಟರ್ ಆಗುತ್ತಾ, I to the power 5 ಅಂದ್ರೆ you can write it is I to the power 4 into I. I to the power 4 is plus 1, 1 into I is, it is just I only. So I am writing all these numbers with some basis. ಏನು ನನಗೆ ಬೇಸಿಸ್ ಅಂದ್ರೆ I ನ ಪವರ್ ಎಷ್ಟಿದೆ 1 ಇದೆ, I ನ ಪವರ್ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ 3 ಇದೆ. ಇವೆರಡು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಅಂದ್ರೆ ಇವೆರಡರದ GCD 1 ಅಂತ. ಓಕೆ, ಹಾಗೇನೆ ಸೊ I ನ ಪವರ್ 1 ಇದೆ, ಇಲ್ಲಿ I ನ ಪವರ್ 5 ಇದೆ. ಇವೆರಡು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆದ್ರೆ ಎಸ್ ಇವೆರಡು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್. ಸೊ 1 and 5 are relatively prime. So I to the power 5 is also a generator. The next property is based on this one. So next property ಏನು ಹೇಳುತ್ತೆ ನೋಡೋಣ. In a cyclic group, it is generated by an element A. ಹೀಗೆ ಬರೆದ್ರೆ ಅರ್ಥ ಏನಿತ್ತು, ಸೊ A ಇಂದ ಜನರೇಟ್ ಆಗಿದೆ ಈ cyclic group ಅಂತ. Okay. In a cyclic group A of order D, what is the order of the group? Cyclic group A of order D, it consists of D number of cyclic group A of order D. That means you can consider that order of an element A is also D. Group na order D irutte, A na order kuda D irutte anta itkolona. Okay, and A to the power of K is a number that is less than D. A to the power of K, so K is a number that is less than D, is also a generator. That is also a generator. If and only if ಅದು ಜನರೇಟರ್ ಆಗಬೇಕು ಅಂದ್ರೆ K and D are relatively prime. K and D are relatively prime. ಸೊ ಅಥವಾ ಇನ್ನು ಬೇರೆ ತರ ಇದನ್ನ ಹೇಳೋದಾದ್ರೆ, what is the order of I? Order of I is 4. Okay, so if you take I to the power 3, okay, I to the power 3, is that 3 is relatively prime with 4? Yes, so ಹಾಗಾದ್ರೆ ಇದು ಕೂಡ ಜನರೇಟ್ ಆಗುತ್ತೆ. So I to the power 5, is that 5 is relatively, and condition ಇದೆ, it should be less than D anta. Okay, so I to the power 3 is also the generator because 3 is relatively prime with 4. That means their GCD of 3 and 4 is 1. Okay, so in a cyclic group of order D, A to the power of K is also a generator if and only if K and D are relatively prime. So we have to prove this result. Now, to prove this result, first you take one group that is generated by an element A. Okay, so let take the proof. Let G is a group, it is generated by an element A. So and they are given that order of G is D and order of A is also D. So according to third property, ಒಂದು cyclic group ಅಂದ್ರೆ group ನ order ಎಷ್ಟಿರುತ್ತೆ ಅದರ generator order ಕೂಡ same ಇರುತ್ತೆ. Since order of G is D, so which implies that order of an element A is also D. So ಅದು ಕೂಡ same ಇರುತ್ತೆ because order of G is same as order of an element A according to third property. Okay, so next ನಾವು ಈಗ ಏನು ಪ್ರೂವ್ ಮಾಡಬೇಕಂದ್ರೆ A to the power of K is also the generator, ಅಥವಾ A to the power of K generator ಆಗಿದ್ರೆ K ಮತ್ತೆ D ಎರಡು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗುತ್ತೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Okay, to prove this, now you take A to the power of K be a generator of G. ಇದು ಎರಡು ಪಾರ್ಟ್ ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗಿರೋದ್ರಿಂದ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ನಾವೇನ್ ತಗೊಳ್ಳೋಣ ಅಂದ್ರೆ A to the power of K is the generator of group G ಅಂತ ತಗೊಳ್ಳೋಣ. So let A to the power of K be a generator of group G. Okay, so then so now A is equal to, where is A ಎಲ್ಲಿದೆ, ಗ್ರೂಪ್ G ನಲ್ಲಿದೆ. ಗ್ರೂಪ್ G ನ ಜನರೇಟರ್ ಯಾವುದು, A. ಹಾಗೇನೆ ಇಲ್ಲಿ ಯಾವ್ದನ್ನ ಜನರೇಟರ್ ಅಂತ ತಗೊಂಡಿದೀವಿ, A to the power of K ನ ಜನರೇಟರ್ ಅಂತ ತಗೊಂಡಿದೀವಿ. ಸೊ A to the power of K ಜನರೇಟರ್ ಆಫ್ G ಆದ್ರೆ ಸೊ ಜಿ ನಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ನ ಇನ್ ಪವರ್ಸ್ ಆಫ್ ಎ ಪವರ್ ಕೆ ನಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. ಸೊ ಎ ಜಿ ನಲ್ಲಿದೆ ಅಂದ್ರೆ ಸೊ ಯು ಕ್ಯಾನ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ದ ನಂಬರ್ ಆರ್ ಎಲಿಮೆಂಟ್ ಎ ಇನ್ ಪವರ್ಸ್ ಆಫ್ ಎ ಪವರ್ ಕೆ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಹೇಗೆ ಬರೀತೀನಿ ಅಂದ್ರೆ ಸೊ ವಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಎ ಹ್ಯಾನ್ ಪವರ್ಸ್ ಆಫ್ ಎ ಪವರ್ ಕೆ such that a is equal to a power k to the power some integer, you say some s, for some integer yes, for some integer yes. So now you take that, which implies that so operate both sets with a inverse. A inverse in operate mana, which is equal to a power k to the power s na we can write it is a power ks to a inverse, which implies that a into a inverse means it gives an identity element e. E is equal to a power, if you operate this it gives that a to the power of ks minus 1, a to the power ks minus 1. So ಹಾಗೆ order of an element a is also a is the d ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay, since order of an element a is d, so therefore so a power d ಹಾಕಿದ್ರೆ ನಮಗೆ ಏನ್ ಬರುತ್ತೆ, ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರುತ್ತೆ. So d is the least positive integer such that a power d is equal to e. ಬಟ್ ಇಲ್ಲಿ a power ks minus 1 ಆಗ್ತಾಗಲೂ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬಂದಿದೆ ಅಂದ್ರೆ ಸೊ d ks minus 1 ಅನ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅಂತ ಅರ್ಥ. ಸೊ ಐ ಥಿಂಕ್ ಯು ನೋ ದಿಸ್ ಪ್ರಾಪರ್ಟಿ. ಸೊ d divides ks minus 1. So you can write that like this, d divides ks minus 1 ಹೀಗೆ ಬರೆದ್ರೆ ಡಿವೈಡ್ಸ್ ಅಂತ. ಓಕೆ, ಹೀಗೆ ಒಂದು ಬಾರ್ ಹಾಕಿದ್ರೆ ಡಿವೈಡ್ಸ್ ಅಂತ. ಸೊ d divides ks minus 1. ಸೊ d ks minus 1 ಅನ್ನ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಈಗ ನಾನು ಈಗ ಬರೀತೇನೆ 2 divides 6 ಅಂತ. 2 divides 6 ಆದ್ರೆ 6 ಅನ್ನ ಮಲ್ಟಿಪಲ್ ಆಫ್ 2 ಆಗಿ ಬರೀಬಹುದು. ಓಕೆ, ಸೊ d divides ks minus 1 ಅಂತ ಬರೆದ್ರೆ ks minus 1 ಅನ್ನ ಮಲ್ಟಿಪಲ್ ಆಫ್ d ನಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. ಸೊ ಹೇಗೆ ಅಂದ್ರೆ therefore ks minus 1 is equal to d into some q. So what is q? Q is some integer. For some q belongs to I. I means it is an integer. I means it is an integer. That is, so you can write this relation like this, which implies that ಇದನ್ನ ಹೇಗೆ ಬರೆಯಬಹುದು ಅಂದ್ರೆ which implies that ks minus dq is equal to 1. ks minus dq is equal to 1, which implies that ks minus dq is 1. ks minus dq is 1, which implies that k and d are relatively prime. K and d are relatively prime. So only when it is possible. So if you express the numbers here, s and q are integers. S and q are integers. Okay, and k and d are the numbers. So if we express these relations between s, q, k, d like this, so then we say that k and d are relatively prime. Okay, so ಬೇಕಾದ್ರೆ ನಂಬರ್ಸ್ ತಗೊಂಡು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿ ನೋಡಿ. ಸೊ ಈಗ ಬರ್ಲಿಕ್ಕೆ ಆಗಿದೆ ಒಂದು ನಂಬರ್ ಅಂತ ಅಂದ್ರೆ ಸೊ ದಿಸ್ ಈಸ್ ಪಾಸಿಬಲ್ ಓನ್ಲಿ ವೆನ್ ದೀಸ್ ಟು ನಂಬರ್ಸ್ ಆರ್ k and d are relatively prime. ಆಗಿದ್ರೆ ಮಾತ್ರ ಇದನ್ನ ಈ ತರ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು, ಅದರ್ವೈಸ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ನಂಬರ್ಸ್ ಥಿಯರಿನಲ್ಲಿ ಇದರ ಬಗ್ಗೆ ಡೀಟೇಲ್ ಇದೆ. ಓಕೆ, ಇಫ್ ಪಾಸಿಬಲ್ ಯು ರೀಡ್ ದಿಸ್. ಸೊ ವಿಚ್ ಇಂಪ್ಲೈಸ್ ದಟ್ k and d are relatively prime. ಬೇಕಾದ್ರೆ ನೀವು ಏನ್ ಮಾಡಿ ಅಂದ್ರೆ ನಿಮಗೆ ಡೌಟ್ ಇದ್ರೆ ಎರಡು ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಅಲ್ದನೇ ಇರೋ ನಂಬರ್ಸ್ ತಗೊಳ್ಳಿ ಅಂಡ್ ಟ್ರೈ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ಲೈಕ್ ದಿಸ್. ಈ ತರ ಟ್ರೈ ಮಾಡಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋದಕ್ಕೆ. ಸೊ ದೆನ್ ಯು ಸಿ ಯು ಮೇ ರಿಯಲೈಸ್ ವಾಟ್ exactly it is. Okay, so if and only if ಇರೋದ್ರಿಂದ we have to prove converse part ಕೂಡ ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ಯು ಟೇಕ್ ಕಾನ್ವರ್ಸ್ಲಿ. what is converse part? Converse part ಏನ್ ಹೇಳುತ್ತೆ, if k and d are relatively prime, we have to show that a to the power of k is also the generator. ಸೊ ಅದನ್ನ ಇಲ್ಲಿ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಕಾನ್ವರ್ಸ್ಲಿ so let k be an integer, let k be an integer such that k and d are relatively prime. k ಮತ್ತೆ d relatively prime ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Okay, which implies that there exists two integers you take that s and q such that if k and d are relatively prime, then we can express that relation like this. So ಎರಡರ ಮಧ್ಯದಲ್ಲಿರೋ ರಿಲೇಷನ್ ಅನ್ನ ಹೀಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. So like this, ks plus qd is equal to 1, ಅಥವಾ ಇಲ್ಲಿ ಮೈನಸ್ ಹಾಕಬಹುದು, no problem. So it is ks plus qd is equal to 1. So better you read a numbers theory concept somewhere. Okay, it is not possible to explain in detail everything because ಇದೆಲ್ಲ ನೀವು ನಂಬರ್ ಥಿಯರಿನಲ್ಲಿ ಓದಿರ್ತೀರಿ PU ಕ್ಲಾಸಸ್ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ನಾನು. ಕೇಸ್ ಒಂದು ನಂಬರ್ ಎರಡು ನಂಬರ್ಸ್ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಆಗಿದೆ ಅಂದ್ರೆ, so the relation between the two numbers can be written like this. So which implies that, so 1 can be written as 1 is equal to ks plus qd. So a to the power of 1 is equal to a to the power of ks plus qd. So now we can write like this, which implies that a to the power of 1 means it is a, and we write it is a to the power of ks into a to the power of qd, which implies that a is equal to a to the power of k into whole to the power of s, and a to the power of qd can be written as a power d whole power q. So the order of an element a is d. So a na order d irodrinda order of a is d. So a power d is equal to e agutte. So this is e. A is equal to a power k into whole power s into e. So that is a is equal to a power k into whole power s. That means we can express a number a in powers of a power k. So a power k ನಲ್ಲಿ ಅದನ್ನ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು ಅಂತ ಅರ್ಥ. So any number a can be written as powers of a power k. ಹಾಗಾದ್ರೆ ಗ್ರೂಪ್ ಜಿ ನಲ್ಲಿ ಒಂದು ಎಲಿಮೆಂಟ್ ತಗೋಣ. So ಗ್ರೂಪ್ ಜಿ ನಲ್ಲಿ ಒಂದು ಎಲಿಮೆಂಟ್ ತಗೋಣ. Let g belongs to g be any element. It is any element of group G. Okay, so which implies that G na ನಾವು ಈಗ ಬರೀಬಹುದು ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. G is equal to a power n. n ಅಂದ್ರೆ, so it is some integer. For some integer n. For some integer n. So and a is a generator. So yes, the generator of the group G is a. So G ನಲ್ಲಿ G ಇದೆ ಅಂದ್ರೆ G ನಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ನ ಹೀಗೆ ಬರೆಯಬಹುದು. So you can express an element of G in powers of a. So like this, G is equal to a power n. So now G is equal to a power n, which is equal to a power. You know that a can be written as a power k whole power s. A power k whole power s, that to the power of n. So which is equal to a power k whole to the power of s. A power k whole to the power of sn. What it indicates, ಇದೇನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ g ಅನ್ನೋದೊಂದು ಎಲಿಮೆಂಟ್ ಗ್ರೂಪ್ g ನಲ್ಲಿ ತಗೊಂಡಿದ್ದೇವೆ. ಓಕೆ, s ಅಂದ್ರೆ ಏನು ಇಂಟಿಜರ್, n ಅಂದ್ರೆ ಏನು ಇಂಟಿಜರ್. Integer into integer is an integer. So G na ನಾವು ಫೈನಲಿ a power k to the power of some integer ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದೀವಿ. So that means like this we can express all the elements of G, group G ನಲ್ಲಿರೋ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ನ in powers of a power k ನಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು. ಅಂದ್ರೆ so a power k is also the generator of the group G ಆಗುತ್ತೆ. So therefore every element every element of G is expressed as a expressed expressed as some integral power of a power k. ಸೊ ಹಾಗಾದ್ರೆ a power k ನ ಜನರೇಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಸೊ therefore a power k is also a generator of G. ಒಂದು ಗ್ರೂಪ್ ನ ಜನರೇಟರ್ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಆ ಗ್ರೂಪ್ ಅಲ್ಲಿರೋ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನ ಆ ನಂಬರ್ ನ ಪವರ್ಸ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋಕ್ ಆಗ್ಬೇಕು. ಸೊ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಟು ಜನರೇಟ್ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ G by using some element. So then we consider that is the generator of the group G. A power k ನಲ್ಲಿ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ನ G ನಲ್ಲಿ ಇರೋದು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ A power k ಏನಾಗಿರುತ್ತೆ G ನ ಜನರೇಟರ್ ಆಗಿರುತ್ತೆ. ಓಕೆ. Yes, I know the difficulties in understanding groups, but you have to follow this. Okay, so I have to discuss some more properties in next coming classes. Thank you.